Hello, today we are going to discuss a numerical of electrostatics. The first numerical is if 100 joule of work has to be done to move a charge of 4 coulomb from a place or from a point having potential minus 10 volt to another point having potential V, then calculate the value of V. What is the numerical? If 100 joule of work has to be done to move a charge of 4 coulomb from a point having potential minus 10 volt to another point of unknown potential, then we have to calculate the value of unknown potential. We have to calculate the value of potential at that point. Calculate the value of V. V means potential of the second point. What is the first point? So this is the first point. Having potential minus 10 volt. This is the second point of unknown potential. And how much work has to be done? 100 joule of work has to be done. So therefore, we have to calculate the value of V. So in the first lectures, we have written one statement, W is equal to Q, VB minus VA. So if we move a charge, I think the figure is like this. This is the directions of electric field. I have taken 2 points. This is the point A, this is the point B. I call potential at A VA, potential at the point VB. According to the numericals, potential at A is minus 10 volt and potential at point B is V. It is unknown to us, therefore we have to calculate it. And we move a charge Q in this direction. What is the value of Q? Q is the 4 coulomb. The expression is W Q VB minus VA. So W is 100 joule. This is 4 coulomb. Potential at B is V. It is unknown to us. Potential at A is minus 10 volt. Okay. So if I divide it, 100 by 4. This is V plus 10. What is 100 by 4? 100 by 4 is 25. So it is V plus 10. So minus plus, therefore it is V plus 10. So from here, 25 minus 10 is equal to V. Therefore, 15 is equal to V. This implies potential of the second point is 15. Potential of the second point is 15 volt. Potential of the second point is 15 volt. Is it clear? So W is 100 joule, Q is 4, VB is V. We have to calculate it. VA is minus 10 volt. Minus plus. So V plus 10. 100 by 4. 100 by 4 is 25. 100 by 4 is 25. So 20, this 10 is taken on the left hand side. So it is minus 25 minus 10 is V. So 25 minus 10 is 15. So V is 15 volt. Now we want to solve. The second numerical. And in the second numerical, the statement is if electrostatic potential in the region of space around a point P having coordinate -1 meter, 2 meter, 3 meter is V is equal to 2x square minus 4y square plus z square volt. Calculate the three components. Of the electric field. Three components of the electric field at that point. So what is the second numerical? If potential in the region of space around the point P, what is the coordinate of the point P? -1 meter, 2 meter, 3 meter is V is twice x square minus 4y square plus z square. Calculate the three components of electric field around that point. So in the second lectures, we derived one relation. Can you remember? E is equal to minus dV by dr. Can you remember this expression? E is equal to minus dV by dr. So what is the significance of this expression? The electric field is the negative potential gradient. That means electric field is directed from higher potential to lower potential. Negative gradient means decreasing potential. So electric field is directed from higher potential to lower potential. Electric field is directed from higher potential to lower potential. So this was the expression E is equal to, can you remember it? E is equal to minus dV by dr. So V is written as 2x square minus 4y square plus z square. So here electric field varies. Here electric field potential varies with x coordinate, y coordinate, z coordinate. Or we can say that our electrostatic potential is function of x, y, z. So therefore, in order to calculate x component, we have to differentiate this function with respect to x. This is called partial differentiation. We have to differentiate the potential with respect to x. So Ex is equal to minus del V by del x. So minus del by del x twice x square minus 4y square plus z square. So if I do this differentiation, minus 2 del by del x square minus minus plus 4 del by del x y square and minus plus minus del by del z, sorry, del by del x z square. Okay, is it clear? So we have to differentiate the entire function. We have to differentiate the entire function with respect to x. With respect to x. So if I do this twice, 2 into x to the power 2 minus 1 plus 4 into 0 minus 0. Why? Because y cannot be differentiated with respect to x here. Y square cannot be differentiated, therefore it is 0. Z square cannot differentiate with respect to x, so therefore it is 0. So if I do this, so this will get minus 4x square. Minus 4x square. What is the x coordinate of the point P? Can you remember? I think x is equal to minus 1 meter. Therefore Ex is equal to, value of Ex is equal to, therefore value of Ex is equal to, so this is minus 2 twice x 2 to the power minus 1. 2 to the power minus 1 is 1. So it is twice x. 2 into 2, 4. So minus 4x. So therefore x component of the value is minus 4 into minus 1 is equal to plus 4 Newton per coulomb. Is it clear? So this is 4 Newton per coulomb. So we are getting Ex is equal to 4 Newton per coulomb. The value of Ex is equal to 4 Newton per coulomb. Now we have to calculate the y component of the electric field. For that, we have to differentiate the potential function with respect to y. X with respect to y. We have to differentiate it with respect to y. So what is the expression? The expression changes like this. Okay, its expression becomes like this. Now when we differentiate x square with respect to y, we are getting 0. When we differentiate y square with respect to y, we get twice y whole to the power 2 minus 1. Again, when we try to differentiate z square with respect to y, again we get 0. That means we are getting 8y here. So Ey is equal to 8y. Ey is equal to 8y. What is the value of y coordinate? Y coordinate is 2 meter. Therefore, value of Ey is equal to 8 into 2 is equal to 16 Newton per coulomb. So Ey is found to be 16 Newton per coulomb. 16 Newton per coulomb. Have you got it? Now we have to calculate the z component. So in order to calculate z component of electric field, we have to differentiate the potential function with respect to z. So minus twice del by del z x square minus minus plus 4 del by del z y square minus del by del z z square. So here minus 2 into 0, because we cannot differentiate x square with respect to z. Under this situation, we cannot differentiate y square with respect to z, therefore it is also 0. It is also 4 into 0 means 0. If we differentiate z square with respect to z, we are getting twice z whole to the power 2 minus 1, twice z to the power 2 minus 1. So Ez is found to be minus twice z. What is the value of z coordinate? 3 meter. So value of Ez is equal to minus 2 into 3 is equal to minus 6 Newton per coulomb. So this is the value of z component of the electric field. This is the value of z component of the electric field. Okay. Now what is the electric field? E is equal to Ex I cap Ey J cap plus Ez K cap, because electric field is a vector quantity. What is the unit vector along x-axis I cap? What is unit vector along y-axis J cap? What is the unit vector along z-axis K cap? It is already discussed in HS first year. I think in mathematics class also it is already discussed in our college. So therefore, what is E? E is equal to, what is the value of Ex? মই তলত লিখি থৈ দিছিলোঁ, value of Ex is equal to 4. Value of Ex is equal to 4 Newton per coulomb. So 4 I cap. Value of Ey is equal to 16 Newton per coulomb. So 16 J cap, and value of Ez is equal to minus 6 Newton per coulomb. So minus 6 K cap. Therefore, electric field intensity around that point is equal to 4 I cap plus 16 J cap minus 6 K cap Newton per coulomb. Is it clear?